setting up a Python development environment with your typical tools that you would use for developing an App Engine application. Just a little bit about myself to start out with. I do work for Google. I've worked for Google for over 5 years. For more than 2 of those years, I worked on App Engine. I was with the App Engine team when it launched in 2008. These days I work on Google Developers. That's developers.google.com. It's a website that's resources for developers, documentation for the developer products, including the documentation for App Engine. So if you're not familiar with developers.google.com, you soon will be. Any feedback or comments on the website, I would be happy to hear them. I'm also the author of Programming Google App Engine, a book published by O'Reilly Media. The first edition came out in 2009, which was a while ago. I am currently working on a second edition that's due out this summer. You can buy access to the early release, so you can get the ebook as I'm writing it. You get all the intermediate drafts. You can watch me fix my mistakes, and you can send me feedback, and they get integrated into the final. If you buy the early release, you get every copy up to the final ebook, which again should be due out later this summer. So lots to talk about today. I gave a webcast a few weeks ago, and if you attended that one, you noticed that I tried to cram a lot of information into an hour, just sort of get a lot of stuff in there. Rest assured, I have not learned my lesson. This hour is going to have a bunch of stuff in it, and we probably won't have time to get through it all. So I may talk kind of quickly. I just shared the slides so that you can follow along later. If there's anything I gloss over or go too quickly, hopefully you can get back to the slides and see what there is. Post a question in the Q&A section, and we can answer your questions at the end of the hour. So you're probably already familiar with Google App Engine. Just to recap and set some context, Google App Engine is a platform for building scalable web applications. You provide the code for your application, and App Engine takes care of putting it on as many servers as it's needed to handle the traffic to your web application. App Engine will create more instances of your app as needed as your traffic grows, and as your traffic subsides, it will shut down those instances and make efficient use of resources, all without needing any code from you to deal with the scaling aspect of that, so you can focus on what your application does. It's built on Google infrastructure. That means a couple of things. Important for today, Google App Engine is, you could describe it as a service-oriented architecture a little bit. So in addition to your application running on one or more instances on these machines, it's going to perform some computation. It'll receive a request. You can perform some computation, and then you can call other services to perform certain kinds of tasks. Each of these services has its own scalable architecture. So for storing data in a scalable data store, we've got a scalable memory cache, a scalable service for fetching URLs for web services or fetching web pages, that sort of thing. So those all services all scale in their own way, and your app is going to call the App Engine APIs in order to access that infrastructure. You pay for what you use. The resources that your application consumes are all billed at a highly granular level. So as your traffic increases, you pay more, but only as you get more traffic. So if you're just starting out and it's a small application not getting much traffic, you're not going to pay very much. You pay for the number of apps you have, the number of instance hours, how long each of those instances is live and running your application. You pay for storage, bandwidth, service calls. And it's free to start. Each one of these resources has a certain amount, a certain limit set, so that if you're just starting out, all you have to do is sign up. You don't even need a credit card. You can create an App Engine application and start serving traffic right away. App Engine launched in 2008 with Python support. It was exclusively Python for a while. They started out with Python 2.5, a Python 2.5 runtime environment. Then they launched a Java runtime environment, an environment for the Go language. And then more recently, a new environment for Python 2.7. The Python 2.5 environment is still around to support old apps, but if you're going to create a new Python app today, you would definitely use the Python 2.7 runtime environment. It's got all the latest features and is basically what's going to be the nature of Python going forward. App Engine is all about easy development. You create your application using the App Engine SDK. The SDK includes a little App Engine simulator. It's the App Engine development server. We'll talk about that extensively today because it's part of your development environment. It all runs on your local machine, so it's running your application, it's serving requests, and it's simulating all of those services that you can call, so you don't need a network connection to develop and test your application. And then when you're ready to deploy your application, that's also really easy. Usually it's a click of one button or a run of one command to get your application onto App Engine and serving traffic. There are no servers to manage. There's no operating system to update. App Engine takes care of all this for you. All you're writing and providing is Python code and files that your application can serve. And then App Engine takes care of setting that up into a Python runtime environment that's automatically scaled. These technologies are all based on standards. A lot of things you'll be familiar with. Specific to Python, there's Python 2.7. You get the Python interpreter, and you get the standard library. The interface to your application is WSGI, the Web Server Gateway Interface, which means it's compatible with many of the extremely powerful and rich application frameworks that are available for Python. We use Django, Pyramid, Flask, all of these, Web2Py, they all work with App Engine really well, all through WSGI. So for today, we're going to talk about setting up a development environment. We're going to talk about the various tools and IDEs that you would normally use for developing a Python application, especially a web application, and how you would use these with App Engine. We'll talk about unit testing. A really important part of a development environment is get unit testing up and running. And if we have time, I'm already a little bit worried we won't have time, but this is a little bit at the end about remote access. I'll explain what it is if we get there. If we don't get to it, it'll be in the slides and you can see it there. There's just so much to talk about here that we just won't have time to get to it all. If we want to do, I'd be happy to do more than one of these webcasts on Python topics. Maybe we can set a couple more up for later in the year. So first a demo. Let's see here. Let me minimize you guys so we can look at this stuff. So typically you would use the App Engine SDK. The App Engine SDK comes with this tool. We just call it the launcher. You're looking at the Macintosh version of the launcher. You don't need to use the GUI or the windowed version of this. There are command line tools that do all the same things. So if you're more comfortable with that, or if you want to integrate this into a larger build and deployment environment that you've already set up, you can do that with the command line tools. But the launcher is a great place to get started. The launcher provides all the basic features of these commands. It also allows you to create new applications really easily. I'm going to go ahead and create a new one here. Let's just call it O'Reilly demo. It's going to create it in a directory. We'll create a new directory for the files. I'll just say create with some starter files there. If I click on the edit button here, it's going to open a text editor, in this case TextMate for Mac. You'll see here it's created the directory with 4 files in it. One of these is app.yaml. It's your main configuration file. The next main one to know about is the main.py source file. You'll see how that's connected in a moment. Let's just take a look at main.py. Delete this unnecessary copyright notice. This is now our code for developing our web application. You'll see here it's a pretty simple thing. This is going to use a web application framework called WebApp2. It's included with App Engine. You can also use Django or any of the others that you want for your own application. WebApp2 is really simple. You can sort of see what it looks like just from looking at this. You create these request handlers by creating classes that subclass WebApp2.requestHandler. Each of these classes gets a method that handles HTTP methods. So this is going to handle GET requests, and it's going to respond by writing out hello world to the response data. And then we're setting up a WSGI application instance in this global variable called app. And here we're mapping some URLs. So this is going to say the root URL is going to go to the main handler. You can have more than one of these in a single app. So pretty straightforward. You can guess what this is going to do, right? It's going to display hello world when you go to the root of the page. Before we see that, I want to show you the app.yaml file. This is the configuration file that every App Engine application has. It has a bunch of things in here. First of all, it identifies your application. So when you register for a new application, you get an application ID. You put that in this configuration file so all the tools know how to interact with App Engine for your application. you can assign a version ID to your application. This is really useful. There's always one version that is live and public, available to your users, but you can have up to 10 versions that you can access individually, so that you can deploy a separate version and test it before making it the default version that everyone sees. That's all managed with the administration console, which is a web-based UI on App Engine for managing your application. So that's a really useful thing. We won't really talk more about that today, but definitely look at that as part of your deployment workflow. Here we're identifying the runtime environment we want. We want Python 2.7. The runtime environments are also versioned. They haven't actually incremented the API version for the runtime environments yet, so this is just set to 1. But if they ever make a backwards incompatible change, or if they ever need to, they will increment the major API version, and your app will continue to use the runtime environment version that is in your configuration file. So nothing changes out from underneath you. If there's a new backwards incompatible version, you can go in and test on your own schedule. You can test it, and then you can increment this in your app.yaml file. The Python 2.7 runtime environment is multi-threaded. This is really important. You want to keep multi-threading turned on if at all possible. If your code is thread safe, you want to set this up. It's important for making the most out of each of those instances that App Engine is going to turn on. With multi-threading enabled, each instance can handle multiple requests concurrently, and you really want to do that if possible. It's really important for making the most out of each of those instances, since you're paying for the amount of time each instance is turned on. With thread safe turned off, each instance can only handle one request at a time, and App Engine has to create new instances to handle more traffic. But obviously this is a switch, because you have to decide for yourself if your code is thread safe. In Python, that's not too hard to do, but definitely something to think about as you're writing your code. The main section that you probably care about for hooking up your application to your code is the section on handlers. The starter files that the launcher created for us created 2 handlers for us here by default, and you can obviously add more. The first kind illustrates a feature of App Engine regarding static files. So if you've got images or JavaScript or CSS or something like that, something that's served verbatim and doesn't change, you can set these up as static files, and they are served from a separate set of servers that are optimized for static files. So you declare those here in the app.yaml file. They are uploaded and they are sent to a separate set of servers that serve static files. So here, as a demonstration, they've included a favicon.ico file, and this is just an example of how to set up a static file. You can also set up a static directory, a directory of nothing but static files. Here's the real meat here, down here. So here's the URL pattern, .star, this is a regular expression that matches every other URL that doesn't match any of the other handlers. These are processed in order. So if it's not for the favicon, it's something else, and that URL gets routed to the application that is declared in main.py. So main is the package name, or the module name rather. And then app is that global variable that we saw that is the WSGI application instance. This is how Python 2.7 hooks up to these various apps. So if you're using WSGI application, you will have a global variable with the WSGI application instance in it, and that's how it connects up. So we can go back to main.p. Here's the main.py. Here's the app global, and there's the WSGI application instance. Each framework will have its own way of setting that up, but you just put it in a global variable in a module somewhere, and then you refer to it in here. We'll talk about this section a little bit more today also. So here I'm declaring that I'm using the Web App 2 library, and I'm using a particular version of the 2.5.1. This is how I declare that I want to use a particular library that is not included in the Python standard library and is not included in the App Engine API libraries. We'll talk about this in more detail, but take a look at this, how I'm doing this. I'm referring to this library and saying, this is what I want, this is what version I want, so that in main.py, when I import Web App 2, it knows what to give me. Now, of course, we actually have to see it running. I'll click the Run button, and I will wait for it to start up. I was having a little difficulty with this last night. I'm not quite sure what is going on. Might be something with my machine. I'm trying to run the Python interpreter. Let me try this again. Riley demo, I click Run. Sometimes actually if I click Logs, there might be a problem. Oh, and there's the problem. Of course it is. My fault. I actually was running through this demo earlier last night, and we're going to talk about how to set up different Python interpreters. I'm going to try and reset this so that it just uses the normal Python interpreter. See if it works now. Yeah, so there we go. So now I'm just using Python 2.7 where it normally is. We'll talk about that in a second. That's something I wanted to show you today. But here I am in a logs window that I opened up with this logs button, and you can see that the server has started up, and now it's available at localhost 8083. So let's, I can actually just use from the launcher. I can open a browser window by clicking the browse button, and there's my hello world. If I go over here and say hello webcast, and I save the file, I can go back to the browser and refresh, and there's hello webcast. I did not have to stop and start the server. The development server knows to watch my local files for changes and tell me and just automatically re-import my modules as needed, so that I can just save my files and refresh. It's a really fast, easy development workflow. So you can see how that all works. We'll talk more about these features here. I'll stop this server here. So you saw that I could get to the logs. I can start my development server. I can also click Edit to open the application directory in my favorite editor. I'll also point out this little button over here. Here's the Deploy button. This is what I would click to actually get this onto App Engine once it's ready to go. It would just upload and it would just start serving. So the development environment. The main thing that we want to consider when setting up our development environment is basically you want to make your computer look as much like App Engine as possible. You're going to be sending this code into a runtime environment that's running on App Engine. App Engine has its own environment set up. It's got Python and various libraries. Basically, this only has to be a rough simulation on your own computer. So it's mostly about installing the right modules, the right packages, and getting the Python and SDK set up. Really, it's a piece of cake. It's not that big a deal. But that's the main goal, is to make your computer look as much like App Engine as possible. So Python development environment for App Engine. Obviously, it's going to have Python 2.7 in it, so you can download and install that if you need to. You'll download and install the App Engine SDK. That gives you the development server, all the API libraries, and all that other good stuff. Then we'll talk today about installing optional packages. Not everything that you would want to use is included with the App Engine SDK. There might be some other things you might want to add. There's a way to set that up. But you want to set it up in a way that is specific to what your app will see on App Engine. And so we're going to use a special tool for that. You might have seen this already. This is a very common thing to do in Python development in general, is to use these tools, virtualenv and pip. And we'll talk about both of those in detail today. But they're very useful when it comes to App Engine. So Python 2.7, obviously you can get that from the Python website, python.org. There are two major tracks of Python right now. Python's being developed both as the 2.7.x track and the 3.x track. The Python 3 makes a few backwards incompatible changes to the language. It's the latest version of the language, but they're still maintaining 2.7.x because people will take their time to migrate to Python 3. App Engine is no exception. App Engine currently supports Python 2.7, so if you're doing App Engine development, you want 2.7 installed. There are currently no active plans to develop Python 3 for App Engine. It's definitely of interest. They'll probably get to it eventually. If they do, it'll be in the form of a new runtime environment. So there will always be the 2.7 environment, just like there's the Python 2.5 environment. They will probably eventually create a Python 3 environment, but right now it's only 2.7. The Python 2.7 obviously gets you the interpreter and the Python standard library. One of the aspects of the runtime environment that your app runs in on App Engine is that it doesn't have every feature available in a typical environment on your desktop or on a server that you set up for yourself. Obviously, in those environments, you can have your Python code access pretty much every aspect of the operating system. For your application to scale on App Engine has to draw a sandbox around your application, that it can only access certain things. If it gave you full access to the operating system, then any app running on the machinery that App Engine runs on might be able to do things that inhibit the scalability of applications running on App Engine. So the sandbox imposes certain restrictions, usually not too onerous, but it's things like creating open sockets, arbitrary open sockets from application servers to other hosts. You can't do in an App Engine sandbox. To help with the sandbox, obviously the sandbox is enforced at a lower level when it's actually running on App Engine. But to make it more convenient to develop your application and determine if there are parts, especially independent libraries, that might accidentally try to cross the boundaries of the sandbox, App Engine will actually patch parts of the Python standard library that wouldn't work anyway. So large portions of the socket library, for instance, are patched by App Engine so that if you try to call into it, you get a sensible exception instead of bizarre behavior. The development server tries to simulate some of those things, so the development server running on your local machine will also try to draw some of those boundaries. It's not as thorough as App Engine in drawing those boundaries, but the parts where it's patching the standard library, it does take care of that to a certain extent for you. If you're running Windows, you just download the Python Windows installer from the Python website. By default, it installs it in the Python 2.7 directory, and if that's in your command path, you can just type the Python command at a command prompt. If you type Python space dash capital V, that'll confirm that Python is installed properly, that it can see it, and it'll show you what version is installed and then quit. So that's a great way to just verify that your Python is installed properly. On Mac OS X, if you're on 10.7 Lion, you already have it. Python 2.7 comes with Mac OS X Lion 10.7. And so you can go to a terminal prompt and type Python space dash capital V to make sure that's true. Some Python developers are not happy with the way Apple has tweaked the Python 2.7 installation. So if you have some reason that you want a more pure Python installation, you can still get a Mac OS X installer from the website. You might also try using a Macintosh open source software package manager like Homebrew. You can install Python through Homebrew. That's a commonly preferred way to do it. And for the record, I have not personally had a need to use anything but the default Python 2.7 on Mac OS X, but your mileage may vary. If you're on Linux, you probably already have it. It's probably installed by default. Ubuntu Precise, the latest version of Ubuntu, does include Python 2.73, so you can go ahead and open a shell window and see which version you have. If you don't have Python installed, the command is usually sudo apt-get install Python. So the next part is the App Engine SDK. If you're going to do App Engine development, this is the URL you want to burn into your brain, developers.google.com/App Engine. This is the complete App Engine documentation and also the download page where you can get the SDK and a bunch of other cool stuff. For Windows, it's just a Windows installer. You download it, you install it. You get a Windows version of that launcher application I showed you as well as the full SDK. Here's the Mac version. It's a disk image file. You download it, you open it up, you just drag the launcher application to your applications directory and launch it like any other Mac application. When you launch the Mac launcher for the first time, it'll actually offer to install the command line tools as symbolic links under user local bin, so they're added to your command path as well if you prefer to do it that way. The Linux version is just a zip file containing the pure Python version of the SDK, all the Python-written tools and all the APIs. I want to draw your attention to this zip real quick because both Windows and Mac SDKs include the complete contents of this, the Linux SDK or the zip file. But it can be a little bit hard to find if you need to actually go digging through the source files or something like that. On multiple occasions I found it's just easier to have a copy of this zip file around so that I can just have a directory that's just Google_App Engine that has the pure Python SDK in it. It's just really useful to have. So you might want to grab this as well while you're there. So as I mentioned, the SDK does include the launcher application. You've already seen this is what it looks like. In addition to the launcher, you get these command line tools. So the development server is this command dev_appserver.py. You would launch it in this way. So you would give it as an argument the path to your application directory, and that starts up the development server. The deployment command, and this command actually has a bunch of different features, but deployment is one of them, is called appconfig or appcfg.py. Its syntax is appconfig.py, some command name, and then the path to your application directory. We'll talk about that a little bit more later. The SDK includes all the API libraries. When you run your application in the development server, those API libraries are already in your Python path, so you don't have to worry about that when you're running in the dev server. But we'll see. We'll have other situations where we care about that a little bit later. The SDK includes all of its dependencies, everything that you need to run the SDK. So you don't have to install any other Python packages. You could just be starting out with a default Python installation with a standard library and nothing else. You download the SDK, and it's got its own copy of everything it normally uses, any third-party libraries that it would use. It has its own copy. If you just run the dev app server command, it knows how to find those as well. There are plenty of other tools in this SDK. Again, we're going to need another webcast to talk about all of them, but I'll mention that one of them is the web app a web application framework that you might use. It's a lightweight web application framework, great for getting started, but a lot of people just love it just because it's small and lightweight and easy to use. An important note about the App Engine SDK, it does not install itself in your Python's site packages. Site packages is where most packages go, most libraries go, third-party libraries go when you install them in various ways. It doesn't become part of your Python installation. It stays in its own directory. You can kind of see how this is important, right? Because a lot of these libraries only make sense in the context of the App Engine development environment. So if they were just sitting around in your Python installation, that might not make as much sense. So optional packages, obviously, I mean, there's a lot you can do with just the Python standard library, Python batteries included, right? It's lots of great stuff is included with Python. The App Engine SDK gives you all the libraries you need to access the APIs for the services and lots of great tools. You get a web application framework like Web App included, so you can build a lot of stuff that way. But for the most part, you're probably going to have dependencies on other third-party packages. Maybe you're going to be parsing JSON messages or creating JSON messages, and you'll want to use the simple JSON library, that sort of thing. In general, what you would do with this is you would include the third-party library with your application code when you deploy it by either copying it into your application root directory or using a symbolic link or something, and then the deployment tools will see, oh, I'll just follow this and grab a copy of this library. And when you upload your application, it includes all your third-party libraries with it. The important restriction there is that those libraries must be implemented in pure Python. So some Python modules have highly efficient routines that are implemented in C. And in Python, this is pretty invisible. There's a lot of great C integration with Python. So when you install these packages, it just uses your local C compiler and installs the library. This is not actually an option on App Engine. As part of the sandbox restrictions, the Python runtime environment on App Engine can only run pure Python code. But there are a few cases where there are packages that are commonly used for web application development that would really benefit from having, that C-compiled backend. Sometimes these packages are just too big to include with your application anyway. You don't want to take all of Django, for instance, and the Django web application framework and include a copy of that with your application. So App Engine has this feature where you can declare that you want one of these libraries, and App Engine will have it for you. It's a small list. It's a fixed list of packages, third-party packages that App Engine can provide. And when you say in your app.yaml file, in your configuration file, that you want one of these libraries, that makes that library available in your runtime environment on App Engine. So if you're using Django, you just say, I want Django version 1.3, please, and then whenever your application imports the Django module or anything from the Django package, it's going to use version 1.3, which is provided by App Engine in the runtime environment. I included in this example Jinja 2, which is a templating library, and also Markup Safe, which is something that Jinja 2 uses for speed. One of the advantages that App Engine can offer you here is that App Engine can actually give you the C-optimized version of these libraries. If these libraries require C code for extra speed up or something, that's something that App Engine has tested and included in the, baked into their runtime environment, so you get the fast version. These are all the packages that are currently available in this way on App Engine. Django, Jinja 2, Markup Safe, LXML for XML parsing, NumPy for numeric processing. The Python imaging library is really useful for manipulating image data, PyCrypto. WebApp 2 I already mentioned, WebOb and YAML. So you get special access to fast implementations on App Engine. These you get versioned access. So if your app requires Django 1.3, you say I want 1.3, and then if 1.4 becomes available later, you're still using 1.3 in your application until you're ready to migrate. So you get this stable environment. But one thing that's important to note about these packages is that they are not included in the App Engine SDK. You have to install them locally. So this goes back to our point about making your local environment look as much like App Engine as possible. Something you need to do if you're going to use any of these in this way is that you do need to install them locally as needed. But so if you think about it, so the App Engine live environment includes the App Engine modules, the sandbox, App Engine's version of Python, and all the libraries that you request in app.yaml. Those are added to your runtime environment. Your development server correspondingly has the App Engine modules provided by the SDK. The simulated sandbox that the development server provides for you, and whatever is in your Python environment. So if you need Django, you install Django, and then it's just part of your Python environment, and your app will just use it there. When you normally install these packages, you use the setup.py script that comes with the package that you've downloaded. You can also use a tool like Easy Install, sort of the old-fashioned way of installing these things. There's a package index, the Python package index, that Easy Install, you just say, Easy Install, go fetch this package and install locally, and it works. It also grabs all the dependencies, very convenient. There's a new version of how to do the same thing as Easy Install called pip. We'll talk about that today a little bit because it's better. Just use pip. If you're used to using Easy Install, you want to use pip. But all these things, by default, are going to add these packages to your site packages. Really, it just becomes one big pile of packages in your Python installation. And you don't normally want this. So imagine, for instance, that you have an app that's using Django 1.3, and then Django 1.4 comes out. And it's not really easy to migrate that app from Django 1.3 to Django 1.4. So you want to leave it on Django 1.3. But you also want to create a new application that is based on Django 1.4. You can't, in your site packages, have two versions of Django like this, because when you say import Django, which one is it going to get? You need some way of managing that. So you have dependency issues, versioning issues. You also have to worry about what if you've installed some libraries locally that App Engine doesn't have? You might be doing other kinds of Python development on your machine, or there's some other dependencies that other tools on your machine use. That's not available to App Engine. If you accidentally create a dependency on one of these libraries and App Engine doesn't have it, then you've got an app that works locally but doesn't work once it gets to App Engine. Then you have the managing different versions and things like that. So how are you going to manage all this? The answer is a Python tool called virtualenv. Not specific to App Engine. It's a general-purpose Python tool, but it's extremely useful for App Engine for this purpose. So you're creating something that looks like App Engine that's separate from other Python stuff that might be going on your machine. So it's creating a virtual Python environment. Each Python environment has its own set of packages. When you use a Python tool, you run a Python script or run your Python application, imports will use whatever's in the active environment. So there's always one environment that it's using at a time. The environment isolates versions and controls dependencies. virtualenv does not come with your machine. It's something you have to install. So you would use Easy Install, for instance, to get it from the Python package instance. You would install it in your Python installation. So you can just use sudo or whatever you need to do this. So typically, this is the installation command, sudo easy install virtualenv. That gets you all the code and a virtualenv command that you would use to create new environments. You would just say virtualenv, and then you would come up with the name of your environment. This creates a subdirectory named after the environment with a bunch of stuff in it. Of course, that directory is going to include all the libraries and packages that you install in that specific environment. It's also going to include a couple of tools for activating and deactivating environments. And so this is how you would activate an environment. You'd say source, because you're modifying your shell environment. This is a shell script that tweaks your shell environment so that it's running in the environment. And you just give it the path within the environment directory bin activate. I want to demo this because it's really cool and it's important. So say I've got here, I've already got virtualenv installed, so I can just say myapp.env, and there I go. Now I have a directory called myapp.env. It's got some stuff in it. It's got the library directories, and it's got my bin there. If I say source myapp.env bin activate, it activates the environment, and you can see it's actually modified my shell prompt to tell me which environment I'm in. It's also created a shell function for me called deactivate, which I can type just without any path. It's just deactivate, and now I'm back to normal. So if I, just as an illustration to send this home here, I start up Python, so I say import Jinja2, and now I actually happen to have Jinja2 installed on my machine in my site packages, so this import succeeds. If I use the inspect module, get file Jinja2, you can see that it's actually getting it from my site packages. Library Python 2.7 site packages is where it goes on a Mac. So it's getting it from my site packages. I break out of that. I activate the environment. Oops. All right. I activate the environment. Now I'm in my environment. I type Python. I type import Jinja2, and it's not there. It's not there because my environment started out empty. The empty environment is just the Python standard library and nothing else, and so I need to install it in here in order for this to work. So now if I do, say, pip install Jinja2, it's going to download and install this. Usually this is fast enough. I was going to do this live here. Let's see if it succeeds. So it's downloading Jinja2 from the Python package index, and it's installing it. And now I have it in my environment. I can go import Jinja2, and it succeeds. I can say inspect, get file, Jinja2, and you can see it's getting it from my virtual environment, not from my site packages. So it's using the version in my site packages. Important thing here is that if I say which Python, the Python command is actually coming from a wrapper script in the active environment. This is one of the ways that virtualenv manages Python. So it's got its own path to Python. It's a wrapper around the existing Python that sets everything up correctly. If I deactivate the environment, then it also resets, which Python is what I meant to say. It also resets my command path so that Python just uses the right thing. We'll see this is important in a second. Okay, so we got that. Okay, so pip, I already showed you pip, and if you've probably seen it before, you might have installed software with it. It's a Python package installation manager. It's like easy install, but better. It has many features. Probably my favorite feature is the uninstall feature. It's something I've always wanted, an easy install that wasn't there. That you can actually uninstall packages that you've installed with pip. It uses the Python package index just like an easy install. And it also works really well with virtualenv, and you just saw me do that. I installed Jinja2 in the virtual environment. I didn't need to use sudo because my virtual environment is owned by me, the user, so I just created the virtual environment and added packages to it. Great if you're in a shared environment as well, a shared machine or something like that. Pip does not come with Python, so you do have to install it. Same deal, sudo easy install pip. You're just kind of bootstrapping pip via easy install. To install a package, you say pip install and then the name of the package. The name of the package is usually something that's known by the Python package index. So if you need to go find that, you can go to the Python package index website, pypi.python.org, and look it up. You can do a search. You can also install a specific version with pip, and it'll make sure that all the dependencies that it's getting correspond with that version as well. So this is how you do that. Say pip install Jinja2 equals 2.6. That's getting version 2.6 of Jinja2. There's a feature of pip that is really useful for setting up an App Engine environment. It's called a requirements file. A requirements file is just a file with a list of package names and versions in it. So I can have a text file that says these are all the things that I use and these are all the versions of the things I use. To install all those packages at once, I just say pip install -r and then the name of the requirements file. You can see how this is going to be really useful for App Engine because in App Engine, I request these third-party packages by their name and version number using app.yaml, and I want the equivalent thing set up in my virtual environment so I can create a requirements.txt file that mention all the same libraries and versions. And now, when I want to create a new virtual environment for this application that has these known dependencies, that this web application that I've created, I just create a new virtual environment, I activate it, and I say pip install with the requirements file, and it just gets everything I need and sets everything up. This makes this environment reproducible. You can check this requirements file into your source control repository, and then if you bring on another developer, they can quickly and easily create a new virtual environment that is set up just to look like the environment for your application. So this is a really useful thing to do for App Engine applications. These are all the names and versions of the packages that I mentioned that are currently supported as third-party packages on App Engine. I singled out the Python imaging library here. You can install the Python imaging library with pip, but the PIL package requires certain C libraries to already be installed, certain image processing libraries. So for instance, if you have the JPEG library installed, you have to have that installed in order for PIL to know how to manipulate JPEGs. It doesn't bring all that in automatically because these are C libraries that are brought in from something else. Installing PIL is outside the scope of this talk. It's a little bit elaborate, but for the most part, it's about installing the other libraries and then installing PIL on top of it. So The trick then, I showed you the Python command on the command line that if I have an active environment and I just type Python, I can use my virtual environment that way. But what about these third-party tools that are starting up the development server for me? So here is a screenshot, and I'll actually do this for you. I already hinted at this earlier when I had my demo was not quite working. If I go to Preferences, the Preferences menu, I can say in this Python path thing, normally I'll just use whatever the default Python is, but I can go my app env bin Python here, and now it will, whenever it starts up the development server, it's going to use the virtual environment. It's going to be via the wrapper script and not the default Python environment. Hopefully, I think I can just click play now and it'll start up. So now it's using the virtual environment. You can confirm that here in the logs. The development server says, well, the Python command I'm using is the one in the virtual environment, and so that's how you know that it's using the right thing. Let's see, what else was I going to say about that? Python wrapper scripts. Yeah, we'll keep going. Yeah. So, I remember what I was going to say about that. If you type a dev app server, here, let me activate my environment again for illustration purposes. I've got devappserver.py on the command line here. You can see it's in user local bin end. It's just for the record, this is you doing the right thing with regards to using your the Python, whatever is in your active environment. So if you just type dev app server on the command line, it will use the active environment correctly because it's using, you see the user bin end Python is how it's invoking that. It's going to use whatever Python's available on the command path. So you don't have to worry about that with the command line. Okay. Oh, so much I wanted to say, not enough time. Okay, so tools and IDEs. I'm going to go faster. So we've talked about devappserver.py, that's the development server console that you can start from the command line. Appconfig is also a command. I won't say much more about the launcher. We've already seen it, but that's included. I did want to show you two IDEs that are really useful for App Engine. They're great for Python in general, but both of these have special App Engine support. The first is JetBrains PyCharm, and the second is Aptana PyDev. You might have heard of PyDev. It is also a plugin for Eclipse, which is it's the same basic deal. But if you're doing a lot of web development, you might consider Aptana Studio 3, which includes PyDev by default. But we'll look at both of these real quick. So the dev app server, you run it this way, you give it that way, runs a local web server, watches your files for changes, reimports modules. Simulates a runtime environment. It simulates storage, so as you're using the data store, the blob store, the memcache, it's saving all that stuff, either memory or disk, in its own local form. If you plan on using the recently launched Google Cloud SQL service with App Engine, and you can, it's a great way to get a SQL database with App Engine, you can set up MySQL locally, and the dev server will simulate your access to that service, so that's useful to know about. App Engine applications can both send and receive mail and instant messages via XMPP. You can simulate incoming messages with the development server. Development server will also run tasks on task queues. It'll help you manage your data store index configuration. I won't talk about that today. That's a data store topic. The development server includes this really powerful thing that everyone should know about called the development server console. I will illustrate it right now. I'll start out with my launcher here. I'll click Run. And from the launcher, this is from the SDK console button. What it is, it's a web UI to the inner workings of the development server, of your simulated runtime environment. So you can inspect what's in your data store. I don't have anything in here right now, but you can inspect the data store, you can inspect what's in your memcache, you can see what your application is doing in the context of the development server, various things like that. One thing I especially wanted to point out is the interactive console. This is a feature specific to the Python version of this. You can type Python code directly into the browser and click Run, and it runs that code in the context of the development server and your application. So maybe your application's already made some changes to the local environment, to the data store or whatever. You can write some arbitrary Python code in here and just run it and see it immediately in the browser. So it's a really convenient way to sort of poke at your app as it's running on the development server. So this is the URL if you're not using the launcher to get to it, if you're just running it from the command line. Localhost, whatever your port number is, /_AH/admin. It's another good URL to know. WebUI to inspect and manipulate development environment includes all of these services. And then the Python console is a really useful feature of that. AppConfig, I won't actually demo AppConfig today, just because who knows what will happen with network traffic and all that, but you can imagine that it'll work. The general syntax is appconfig.py, command name, and then the path to your application directory. The main use of this is to deploy your application. It's the update command. With appconfig, you can also manage your data store indexes. A couple of commands for that. Downloading your application codes. If there's some kind of disaster with your source control repository or something like that, you can download your Python code that you uploaded last time you deployed. Kind of an emergency measure. You really want to be using source control to avoid having to need that, but if you need it, it's there. You can also disable that for the record. If you're working with multiple developers and you don't want them downloading all the code that's on the application for whatever reason, you can permanently disable that feature. You can also manipulate data store data, doing imports and exports. You can also download your activity logs, your request logs for offline analysis. That's a really useful thing to do here. Many of these features are pretty much only the deployment feature is available from the launcher. These others you have to use the command line tool for. So it's useful to get familiar with the command line tool, even if you're using the launcher. A couple of quick tips about this. AppConfig normally will prompt for your username and password, your Google account username and password. What it actually needs from you is an application-specific password. If you're not familiar with that, that's a Google account feature. For the most part, especially with the command line tool, you want to use OAuth for login. I won't even explain what OAuth is. I just don't have time. But if you say --OAuth2 when you run appconfig.py on the command line, it'll open a browser window to let you sign into the Google interface, and then it'll store a token. It won't store your password, but it'll store a token so that on subsequent runs of the tool, it already knows who you are and what's going on. So that's really useful. I also highly recommend enabling two-factor authentication for your Google account. So if you use the OAuth2 login and two-factor authentication combined, that gives you really secure access to everything you're doing. I just don't have time to talk about that. It's a really important and useful subject. But some of these tools don't support OAuth deployment or access with appconfig. So you're going to need to use application-specific passwords. To create an application-specific password, it's basically a randomly generated string of characters that you would use for one application that you can then revoke through this panel. Just go to google.com/settings and sign in. I wish I could cover it in more detail. We've already talked about the launcher, so I'll skip ahead to JetBrains PyCharm. This is where you get it. It's an IDE. It's a full IDE for Python. Get it at jetbrains.com/PyCharm. It's a commercial product, so you get $99 gets a personal copy. If you want to get a seat for your company, that's $199 for a commercial license. If you're working exclusively on open source projects that have a public website and a mailing list and are all set up as public projects, you can actually request a free open source project license from JetBrains and use it for free. It's also available as a 30-day free trial, so if you just want to get started with it, see what it's like, just download it and you don't have to pay anything to play with it. It's a full IDE. It's graphical IDE, gets you code completion, an interactive debugger with breakpoints and all that good stuff, automatic running of unit tests with coverage reports. I want to show you that in a second if we have time. Complete access to library doc strings, all the stuff you would expect from a graphical IDE. Automatic import, so you can just type the name of a package and as you're using it in the middle of your code, and then tell it to say, yes, this is the one I'm talking about, and it'll add the import to the top of your file. Some refactoring features. It's great stuff. Specific to App Engine, PyCharm includes several features, including an App Engine project template. So when you create a new project, you can say this is an App Engine project, and it knows what to do. It's aware of all the App Engine libraries. When you set up a project that way, it knows all the paths to all the libraries that you need. It can run the development server within its own interactive debugger, which is really useful. And there are actually some menu options for deploying to App Engine and fetching logs from PyCharm. It's also got special development support for Django apps and other web app things like HTML, CSS, and JavaScript. So you get a full development environment for PyCharm, for developing web applications in PyCharm. This is what it looks like. I really wanted to demo it to you live. Let's see if I got enough time here. So here is this is actually the application that runs the website for my book. it's a very simple thing. It's got a handcrafted weblog and some informational pages and things like that. Here you're looking at the code for part of the weblogging engine. I've got this all set up in PyCharm, and here I can just click, let me close this. So you can see I'm using Web App 2 for that. I've got it all set up in here. It's got great syntax coloring. Let me go just for fun. Say I'm in one of these handlers. And I say self dot, type it right, self dot, and here I've got my text completion. It already knows that self is a handler, a Web App 2 handler class, and so this is a great way to access. Here's the response object. It's got this out thing I can use, and I can write to it, and so forth. So yeah, all the stuff that you normally expect with an IDE. I've been a diehard Emacs user since I was like 8 years old, so I'm not really used to, I don't normally set up code completion and things like that. So when I get into an IDE like this, I'm always kind of impressed and astonished and jealous that I'm not using a full-featured IDE. I'm seriously considering using PyCharm for a lot of Python development going forward. But here I've got this set up. I can click the play on a debugger, and it's starting up the Python development environment, or the development server, and it's just showing all the log output here. I've got localhost 8080 down there, and I can go visit it. Localhost 8080, and fingers crossed, there is the version of my book website. I've got some test data in the blog system and all this other stuff, and I can play with it. Let me stop that real quick. Okay, and then it's done. Back to Keynote. Okay, so PyCharm. If you're using virtual environments, PyCharm does support that. So when you're creating a new App Engine project, you create it like this. You set the project type to Google App Engine project, and then it lets you set an interpreter. For this, you would configure an interpreter that uses your virtual environment. So it's the same deal. You're finding the path to the bin/python in your virtual environment. And so here I am setting up, this is a screenshot of setting up the rest of the App Engine part of the application. You enter your application ID, and it knows what it's doing when it creates your application. I'm not going to demo Aptana PyDev. It's very similar to PyCharm. Aptana Studio 3 with PyDev you can get at aptana.com. You can also get PyDev as an Eclipse plugin from pydev.org. One of the best features of Aptana Studio 3 is that it's free. It's based on Eclipse, all open source software. You can just download it and use it to your heart's content. It's very featureful, has many of the same features as PyCharm. Code completion, interactive debugger, all that other good stuff. App Engine support, it has some specific support for App Engine with the project setup wizard. It's library aware, and you can run the dev server and the debugger as before. Special support for developing web applications. Here's a picture of it. By default, it comes with a dark background. This is Aptana Studio 3. I'm sure you can change that if you like. And when you're setting up an App Engine project, there's an App Engine project type for PyDev. If you're using the Eclipse version, it looks almost identical to this. But this is just what looks like an Aptana. So I'm setting it up. I can configure an interpreter, same deal. I can create a virtual environment and use it from Aptana. One little trick with Aptana, if you're using virtual env, you do need to explicitly select the Python standard library when it prompts you for figuring out where all the libraries are. If you don't do this, it'll actually notice that, hey, wait a second, you're missing the standard library here. Are you sure you meant to do this? And it'll give you instructions on how to do that, but you do have to set it specifically. So anyway. Moving on, I've got 4 minutes to talk about unit testing, which is not nearly enough time to talk about unit testing, as anyone who knows anything about unit testing knows. But for unit testing, I mean, you would think, well, this is just all Python code, right? So really what you would need to do for unit testing is you'd activate your virtual env to make sure you're in your virtual environment. You'd make sure Google App Engine, the SDK library, and your app's root directory are in your Python path, because that's the way it would be in App Engine. Normally when you run dev app server, it sets up the Python import path for you in the right way. But if you're just running some Python code in a unit test, you want to make sure this is set up correctly. You might use your own little scripts to set this up properly, so scripting your unit test is just kind of a one-step thing. There are some great test runner scripts, test runner tools available for App Engine. Check out Nose GAE or GAE Unit. Those are both some open source projects that let you do that easily. So just imagine, what we might do for testing our application. Here I'm actually doing this. This is an example of a session on the command prompt. So I activate my environment. I make sure that App Engine is on my Python path. Here, notice that I've downloaded and installed that Linux zip that I told you about in a really convenient path. This is one possible use of that. Then I say Python within the environment. So I've got this interactive REPL that I can access stuff. I can import Google libraries just fine. I can import models. In this case would be the a source file from my own application because I'm in my application source directory. I can create a data store entity object. This way I could set a property on it. And what I would like to be able to do is to call the App Engine method for storing this entity in the data store. So I would just say, entity put please, and it would call that method and store it in some data store, right? That's what I would normally do in code, so I would want to be able to test that. So in theory, that's what I want to be able to do. But you can see the problem with this. If I'm just running pure Python code, just sort of sitting around on my command prompt or within a simple unit testing script, I don't actually have all these services that these APIs access. I'm not within the development server. I'm not on App Engine. So if I try to call one of these things, here's a simpler example of just trying to call the send mail function of the mail API. It's going to say, I don't have a service for that. I don't know what you're talking about. So for that, we have a special utility. It comes with the App Engine SDK called testbed. Testbed is a set of service API stubs that provide a virtual simulated, clean environment for testing purposes that simulates all of these services that you might call from this code. It's provided by the App Engine SDK under a Google App Engine ext testbed. And so it's got a bunch of, these stubs have a bunch of features for testing purposes. So if you're calling the mail and XMPP APIs, it'll actually record the outgoing messages so you can perform asserts on that. The data store, you can mess with the consistency guarantees and do fuzz testing. Users, you can simulate different sign-in statuses, that sort of thing. I really wanted to do this on the command line, but I'm out of time, so I'm just going to show you what's in the slides here. Hopefully you can follow along. What you would do, again, I'm doing this from the REPL, which you can do from the REPL if you want to just sort of poke around. But this is also something you would do within the unit test code itself. So here I would import testbed. I would create the testbed instance. I would activate it. And then I would initialize the stubs I'm going to use. And then from there, everything else I might do is going to work as if it's in a simulated App Engine environment. So you can see the put command now, as it normally would, returns the data store key of the entity that I just created. It's created the system ID, all the other stuff that it normally does when you create a new entity this way. The activating step is important because when you're in a unit testing environment, you want to activate and deactivate. It's a reset mechanism for the testbed instance. So here's another example using mail. This is how the mail would succeed. I would initialize the mail stub after I've activated the environment. I can import the mail command. I can call the mail function, and it just does the right thing. The mail command doesn't actually return anything. It's just going to be successful. But then I can get the stub. This is the code to do that. I would get the mail stub, and then I would get the sent messages that the stub has recorded, all the sent messages to that address, and I can see them in data structure, and I can manipulate them, or I can do asserts against them. Here's actual unit testing code for doing this. So I import unit test. I won't walk through this, but you can see how like the setup and teardown would create and activate, deactivate the testbed. And here, once that's set up, my actual test code can just resemble my application code as you would expect it to. It just does the right thing. You can actually initialize all the stubs at once, but the specific stubs, sometimes some of them take configuration options, so you might call the init specifically with some options. For more information about testbed, here's the URL at the bottom. I don't know if you can see that URL, but it'll be in the slides when you see it. So on this subject of unit testing, you might want to test more than just the small units of code that might call the web service APIs. So if in this case, I might have a web app application, and I've created those handler classes I showed you earlier. So this is an example based on the weblog software I just showed you that powers my books website. One way I can test this, this is a legitimate way of doing it. I can import the blog a module from my own software. I import WebOb, which is what web app uses for request and response objects. And so here I instantiate the handler. I create a request. In this case, I create a blank request. This is a feature of WebOb. It makes it really easy to say this is a request for the home page, for instance. And then I can call the get method, which I already showed you, of the front page handler. With the request object that's already populated on the handler h.request attribute. And then I can, calling the get method, it populates the response object and all that, so I can then perform asserts on the response object. This is a fine way of doing it, but there's a better way using a piece of software called Webtest. Webtest is a test helper for all WSGI applications, and it wraps any WSGI app instance in a WebOb-based interface. So kind of what you just saw for web app, that was very specific to web app. For Django, you would normally have to do something very different, or Pyramid or Flask or any of those. What Webtest does is it takes the application instance itself and gives you a standard interface for sending requests to it and getting responses out of it. It's a third-party tool. It's not included in App Engine, so you do need to install it. Pip install Webtest would do it. Here's an example of how to do it in the context of a unit test. So you set up a testbed the way you normally would, and then you would create this test app, which can just refer to the application global in your application file. So blob.application is what I use in my app.yaml file to refer to this web app instance. I can just refer to that again here using Webtest. And then I just create, I can just send it requests, and I can get the responses back and perform asserts on those responses, regardless of which web application framework I'm using. For more information on Webtest, webtest.pythonpaste.org, or you can go to the webob.org website and learn more about WebOb. I want to show you one more thing. I won't have time for remote access, or if you really want me to, I can spend the last 5 minutes on remote access. But I did want to show you this. I've got here. I've got a test file set up in just this way. I'm using testbed. I'm using Webtest. This is to test my weblog software. I don't have a complete set of unit tests for this code. I did that on purpose so I can show you something. I've set up a test configuration here in PyCharm. This is PyCharm again, and I'm going to run this unit test. These unit tests, this test file, with this test configuration I've set up, and I'm going to run it with coverage. Coverage shows you all the lines of code that are executed during a session of execution. This is a really important aspect, especially for interpreted languages like Python, where a typo or a logic problem in some code that doesn't get run doesn't actually get noticed unless it's run. So what test coverage does is it shows you all the things that your unit tests actually execute. It shows you all the lines of code that get exercised by your tests. So here it's completed, and it's shown me that my meager little blog test file has covered these many lines of these things, and I can go back to my blog.py, and I can see, I don't know if you can see this over the webcast, but there's a little green bar right here saying that, okay, it did call all of those lines, it didn't call these lines, and I can go through and improve my test suite so that every single line is covered. Now, coverage is not a silver bullet, but it's really a good lower bound for making sure that your tests are executing all of your code. Obviously, you want to test a lot more than just the basic coverage, but it becomes a really important aspect to track the quality of your code. I just wanted to show that off because I'm just so impressed that PyCharm has all this stuff built in. It's actually using the Python coverage utility, which you've probably seen separately. That's something you can get separately. If you're not using PyCharm, you can use coverage in your own way, but that's outside the scope of this. So awesome stuff. I like PyCharm a lot. Okay, so I can talk about remote access. I'm going to pause here for questions because we are at the hour, and I want to make sure I have time to answer your questions. So why don't we skip this real quick, and if I've got a couple minutes at the end, I will come back to it. Just to review, we've talked about the development environment with the dev server in Python, setting up optional libraries with a virtual environment in pip, reproducible environments with the requirements files. We talked about tools and IDEs, the launcher, PyCharm, Aptana Studio 3, and Aptana PyDev. Using these IDEs with virtual env, you can set that up in various ways. Deployment without config, a lot of these tools let you deploy directly from the tool as well. Unit testing, we talked about testbed and Webtest and PyCharm code coverage. I skipped remote access. Maybe we have a little bit of time for that at the end. For more information on App Engine, you can go to developers.google.com/AppEngine. To sign up for an App Engine app and an account, and also see the admin console, the administration console for your live running app. Lots of great features I didn't even talk about today. You can see my earlier webcast, which talks a little bit about that. Go to appengine.google.com. For more information about my book, including that book blog, go to ae-book.appspot.com. I am currently working on a second edition of Programming Google App Engine that's going to be due out later this summer. Please buy the early release, get access to the intermediate drafts, send me feedback to get into the final edition. And for more information about me, you can follow me on Google+. There's my profile URL. And that's it. Thank you very much. If you've got some questions, hopefully they've been pushed to the Q&A panel.
Yes, Dan, we have several questions, as you can imagine, that have come in, and they are all right there in the Q&A for you.
Great. Thank you very much, Yasmina. Let me see if I can get to these. All right, let me start with ID number 2. Okay. Can I run Groovy and other JVM languages on Google App Engine? The answer is yes. The Java runtime environment is a full JVM, and you can do things like Groovy and all that other great stuff. You can do Ruby with JRuby. You can use JavaScript with Rhino. All that works. Lots of great stuff. Clojure. I would love to do more with Clojure using the JVM as well. For Django, I would import the Django core libs instead of WebApp2. That is correct. There are ways of setting up Django with that. You would not have to deal with WebApp2 at all. There are ways of setting up Django as a WSGI application in the same way you would refer to it with the app.yaml. RDBMS API error in the logs, how do you fix that is a real problem? It's not a real problem. Some of the things that the dev server emits are basically like, well, if you were to use these features, I would need these libraries, and you don't have these libraries installed. So if you just want to silence them, it's usually a matter of installing a couple of packages to get it to be quiet. But if you're not actually using the features that go through those libraries for simulating access to MySQL, that sort of thing, you can just ignore those. Last time I tried App Engine, there were some disclaimers for Python 2.7 version stating it was still being tested. It is now ready for prime time, yes. They've done a full launch of Python 2.7, so no worries about that. At what point becomes WebApp 2 lightweight, and would you like to use something else? That's a very good question. I think like the larger web application frameworks like Django are best justified by their breadth, I guess. So I know we're using Django for developers.google.com in part because Django has its own way of organizing code into apps. It has its own notion of apps and the separation of responsibilities and things like that. That's been really useful for us as we collaborate with other teams on different apps and things like that. So Django has different ways of managing that. Django has a middleware feature that's really useful for certain kinds of implementation techniques. Django also has lots of third-party libraries that expect the full Django environment, sort of the full stack there. So that's a good thing, a good reason to use something like Django. There's actually an open source product out there called Django App Engine and Django Non-Rel. You can refer to those later that give you greater API compatibility between the Django environment and the rest of App Engine. So all that's good. But really, I've seen a lot of great stuff implemented with the lightweight thing. So not just WebApp2. I think WebApp2 is great, but there's also Flask is another one I would recommend looking at. So yeah, definitely check out the feature set of some of these things. Are there limitations in respect of cross-domain scripting on App Engine, and what are the strategies for overcoming these limitations? Those limitations are inherent in all web application programming. Cross-domain scripting is something you would see in any application that you would do. I would use the same techniques for handling that. There are the cross-domain allowance policies and things you can set in various headers. I will say, specific to App Engine, you can set up your own domain name. You can set up your own application on your own domain name on App Engine. You would set it up with the Google Apps domain and then associate your specific App Engine app with a subdomain of your main domain. So for the most part, and if you're developing a regular application and you're all just on your own application, you don't have to worry about the domain. You've got complete control of the URL in that respect. But otherwise, yeah, that's a standard thing to deal with web applications. The latest Django is 1.4. Will App Engine play nice? I believe the current release has Django 1.3 as the latest one, but there's no reason why they won't add 1.4 soon. So you can just wait for it to become available as one of those optional packages. You can also try to pack Django into your own application directory. That's the way we did it before we had the optional packages feature. So I definitely try it. I'm pretty sure Django 1.4 would work. There's no reason why it wouldn't. But I think the main thing you want to wait for is the next release. I don't know if it's the very next release, but an upcoming release that will add Django 1.4 as an optional package to the App Engine environment. Do you know of any SOAP calls in Google App Engine to try? What Python SOAP library do you recommend for that? I don't. I kind of divorced myself from SOAP a while ago. There was, I think my Python SOAP information is out of date at this point. There was a SOAP library that I used to use a long time ago, and then there was a new one that somebody was working on, but it was really complicated and hard to use, and eventually me and everybody else sort of migrated to REST APIs, and I kind of forgot about SOAP. So I don't have one to recommend. One thing I will say about making a request like that is that the App Engine Python environment will replace the URL lib library, the Python standard library, with something that is compatible with what it actually does. Instead of making a direct socket connection, I mentioned that that's sort of forbidden by the sandbox environment, it'll actually use the URL fetch service to make those calls. So in many cases, that's pretty invisible. A lot of libraries that are just sort of based on top of URL lib can sort of invisibly use the URL fetch service for the same purpose. And so if you do find a SOAP library, it might work, it might not. I actually don't know which ones work and which ones don't. Would love a longer session. Will you be at Google I/O? I will be at Google I/O. I am not speaking this year. I didn't have time to prepare a presentation to get on the docket, but I will be there. I'll be hanging out at the App Engine booth, so come say hi. I'll try to hand out goodies related to my book, and I'll generally be around. So yeah, definitely come find me. As far as longer sessions go, I would be happy to do more webcasts, and there are other constantly Google-related events to App Engine. I might get in on some of those as well. Would I recommend NDB instead of XDB? Absolutely, and I did not have time to talk about this today. There is a new version of the database interface called NDB. The X.db was great. It lasted us for many years, and it's still useful if you still want to use it. But they've been doing a complete rewrite of that, and it's called NDB. It's available. I highly recommend it, especially for its memcache integration. A very common design pattern for using the data store is to, if you've got stuff that you don't need updates to go out to your application right away, and you want faster read access, you want to use memcache in front of it, and that makes it really easy to do. So definitely look into that. There's full documentation on the website now. Message queuing methods. Are there any end-to-end message queuing capabilities on App Engine? Do you have to roll your own with XMPP perhaps? I don't know exactly what you mean by end-to-end message queuing. I guess you mean with the client as well. Certainly, you can build something like that. Just what comes to mind when I read your question is something that I think you could do pretty easily with App Engine. There are the client communication part. You could use XMPP if you want. There's also a web channel API. It's a new thing that you would use some JavaScript in the browser that would allow the app to actually push messages to the running browser code. It's a comment-based comment-like interface. That's a separate service of App Engine. It's a feature I haven't talked about yet, but go check out the channel service if that's what you're asking about. As far as queuing goes, you might be able to get what you're asking for using task queues. It's a really simple thing where an application can say, I want this URL of my own application to be called at a later date. And that gets atomically committed into a task queue, and then App Engine drives those tasks to completion. It's a great way of doing background work or distributing work, parallelizing work across a bunch of tasks. You can even create your own task processing systems with pull queues and other stuff. So hopefully that answers your question. If not, you can email me, find me offline. Yasmina, can I take like 2 minutes to talk about remote access? Just a little bonus at the end here.
Yes, sir. Yes, sir.
All right, thank you. I didn't want to push the limits on our scheduled time here. If anybody else that's watching, if you need to go, if you need to leave, go right ahead. This webcast will be archived, and I will be publishing the slides as well. But I did want to talk about remote access just because it's really cool. So let me go back to that. So I threw this in here because we were talking a lot about the API service stubs, right? So on App Engine, if you call an App Engine library to call a service, it's going to go straight to the service. If you're in the development environment, the development server knows to simulate those services, and so a call to the App Engine library goes to the simulator environment. You already saw the stubs in action too. If you're setting up a unit testing environment, we've got testbed, which basically replaces those stubs with something that calls a clean a testable environment for those services as well, so you can confirm that your services are being called the right way. There's another application of service stubs. If you've done anything with remote procedure calls, you might know what's coming up here. Remote access is a way to replace those service stubs running locally on your machine with an actual web service call to your app on App Engine to call the live services. So you get this pipeline of what's basically allowing you to call the live services in your application on App Engine, but using local code running on your local machine.
Dan, I'm sorry. Can we trouble you to reshare your screen with us? We're not seeing the current slides.
All righty. You haven't missed anything yet, but thank you for mentioning that. I forgot my screen sharing got turned off. I have to hit play. Thank you, Yasmina. So, you see it now? Okay, I assume so. Right, Yasmina? All right.
Yes, it's coming back for us right now. Thank you.
Okay, good. Yeah, I haven't shown anything yet. I was just talking, so you haven't missed anything. But yeah, so remote access, you get the service API stubs that actually use the live site, the service API stubs I mentioned, you would either be on the live site or in a development server or in testbed. Remote access gives you a fourth option where you can configure the API stubs locally to access the live services for your application. You actually set this up using a proxy within your own application. It's really easy to set up. What you do is you activate it as a built-in. Basically, it's setting up a request handler to some library code. You just put this in your app.yaml built-ins, a remote API on. It looks just like this. And what this does is it sets up a request handler on /_AH/remote_API. That's the URL that it's going to use. It is restricted to only administrators can call that URL, so it's completely secure as long, anything that your application administrators can do, it can do, and nobody else can access it, so you can do that. One of the easiest ways of using remote access is to use a tool that's included with the SDK called Remote API Shell. You just you start this and you use your application ID, not the path to your application directory, but your actual application ID. It figures out the rest about how to figure out how to find the remote API URL and set that up. This will actually run a REPL, an interactive command line prompt for Python that gives you access so that when you call these libraries, it's actually calling the live service. Now, note that this does not support OAuth, so you must use an application-specific password. I mentioned that earlier. So it'll prompt you for an email address and then a password that you have to get from this website. The other thing to note about this is that a remote API calls consume application resources. So the remote procedure call to the proxy is incoming bandwidth. Then it actually calls the service, which may incur some resource consumption, and then it actually has to send it back, and so that's more bandwidth. So you're probably not going to use this for really intense batch jobs or anything like that. You can use it for poking around or little scripts, little maintenance scripts that you might run locally. Just to avoid error, I've just copied and pasted a session of this that I did last night into the slides so you can see how you might do this. You would change to your application directory to make sure it's in your Python path. Then you would run the remote API shell with your application ID. So this is what I would do for my book website. I would enter my email, my application-specific password, and then I've got this read eval print loop REPL right here that I can type Python commands directly into. I say import models. Models is my own file from my source code, my application source code. It's got the data models for my weblog stuff. And I can create a query Directly from here, I can say models.entry.all, which sets up a query object to say, get me all the blog entries from my blog, and then I fetch 3 of them from that query. And what I get back is an array of objects, of entry objects, that I can then play with on the local command line. But when it did this query, it did it live. It actually got that from my live running web application, not a simulated environment, but from the real thing. So you've got immediate Python access like you would locally with any other application, but with your live data. The other cool thing about remote access is that you don't have to use the REPL for it. You can actually write your own scripts. It's really simple. This is a very shortened version of how you might do this sitting on the slide here. I've got a more complete example in the book, which I'll make sure is updated and gets in there. But yeah, you can go see the book for a more complete example. But the basic idea is you're setting up the remote API stubs, and then everything else is just calling the App Engine APIs like you normally would. That is it. Thank you guys so much for coming. I really appreciate it.